Okay, fifth video from 6.1. So now we're still dealing with exponents and special notation. We're on the second of those two things to memorize or just accept. So we are in the second part 2. So previously we said, well, what happens when you have an exponent that's 0? So the next question is, what happens when you have an exponent that's negative? Okay, so that's what we're going to be taking a look at is exponents that are negatives. And may I point out one thing that remember, I'm going to remind you of this again. Exponents are just instructions. So before we go on further, I'm going to say in this first 3 to the negative 2, I see two pieces of information up here in the exponent. There's the negative, that's one instruction that's telling us to do something. That's what we've got to learn. There's another instruction, a 2, and we already know what that 2 tells us to do. Okay, so let's take a look at what that negative tells us to do. What's the instruction there? So we're going to, does this look familiar? Do you remember when we were taking a look at the pattern? 3 to the 4, 3 cubed, 3 squared, 3 to the first, 3 to the 0. So we set up a pattern here to try to discover what the pattern would be on the right hand side. So the exponents are decreasing by 1 every time. So what would be the next logical exponent? A negative 1. And then 3 to the negative 2. So we're going to see what they are. And we discovered also that going from one step to the next, we can get there by just always dividing by 3, divide by 3, divide by 3, divide by 3. So we should be able to divide by 3 here. What is 1 divided by 3? 1/3. Oh, cool. And we've got to go now, let's put that in, we divided by 3. So to get the last one, 3 to the negative 2, well, the pattern should continue. We have to divide 1/3 by 3. And let's just do that because that doesn't just come easily. We can't just do that maybe in our head. So we've got 1/3 divided by 3. How do we do that? Well, we take and we change division to multiplication, and you flip the number that comes after. So we have 1/3 times 1/3, and I know you're saying that's 1/9, but can I write that using exponents? 1/3 squared. So we've discovered that. All right, and I'm going, what does it look like happening here? I see the negative over here with the negative 2. That just moves everything. Let me use some red here. That took the base in the exponent and moved it downstairs. When we had 3 to the negative 1, it took the base and the exponent and moved it downstairs because we know we can put a 1 there. Okay, so that is what that negative tells us to do. And to say that in another way, negative exponents say go where you're not. In other words, if you're upstairs, you go down. And if you're downstairs, we'll see in a moment, you go upstairs. And there's a ghost down here, a little blue ghost reminding us exponents are just instructions. And that little horizontal line that we call negative, when it appears up in the exponent, it is telling it that it has a very specific instruction. Okay, so we got to talk about upstairs and downstairs to do a little bit more here. When we have the fraction 5/2, I think you'll all agree. I'm using very loose language here. 5 is upstairs, 2 is downstairs. Okay, so when we have just a plain old 5, there is no upstairs, downstairs. There is no fraction, but let me kind of point something out. We know that 5 is the same thing as 5/1. So will you grant me that just a 5 by itself, if I got rid of that over 1 here, we consider that 5 upstairs? Okay, and I've got some more to say to you before we look at some more examples. You all speak 1 or maybe even 2 or maybe even 3 languages, and you're well aware that in languages a word's meaning depends on the context where you find it. Okay, So, for example, the word root, R-O-O-T. If I say, oh, which team are you rooting for in the Super Bowl? That means one thing. And then in another context, if I say, oh, that plant's roots look kind of dry, it means something else. So context determines the meaning. So I've got to emphasize this. So context, where is that little horizontal line that we're calling a negative? I've got it in red here. When you see it in front of a big number like that, it's what you have always known that little horizontal line that we call a negative stands for. It just flips things back and forth on the number line. So let me emphasize this a little bit more. If we start with 2, so I'm going to put a 2 there. If we throw a negative in front of that 2, what happens is it flips it over here to the opposite side to a negative 2. And if we put a negative in front of that, it would flip it back again and so forth. So this negative in front of a big number flips things back and forth on the number line like this. Okay? Now, this 3 to the negative 2, so we still see that negative, but its context now is it appears not in front of a big number, but it appears inside it appears in the exponent. So it has a different function and it's in a different context. And in flipping, instead of flipping things left to right as it did over in the first case, now it flips things up and down. So if we had 3 squared, that's up, okay? But if we have put that little negative down here, what that does is it flips it and puts it downstairs. And you just put a 1 there. Okay, I think we've got just a few minutes, and I'll summarize, and we've got to do a little bit more with this. So in summary, a to the negative m, what I like to do, so that's anything to the negative. That negative, the instruction is take the base and the exponent and move them where they're not. So now that's considered upstairs, so that means it has to go downstairs. Okay? And what goes upstairs, what's left upstairs? Well, just a 1. That's just what's left over. When it starts downstairs, we see that negative, so that tells us go where you're not. The base and the exponent have to move where they're not, so that means they're going to have to move upstairs because over here they're downstairs. And real quickly, in this last one, we're going to get to this further. So this is the main, these are the main parts, but I just want to show you something very cool. When you have that exponent applying to a over b, that exponent is going to send a downstairs and it's going to send b upstairs. So it's, but we still have to the m. So don't worry about this. This is coming later, but I just wanted to also show you that it just moves everybody. That little horizontal line has a lot of power. It can move everything. We'll be back in the next video with more examples.